Alright, doing quiz number 3 from 2014, the key for this. So take a look at the first question here. It says star all the asymmetric centers for the potent poison strychnine. So asymmetric centers would be sp3 hybridized, bonded to 4 different groups, different things. Been practicing this hopefully. A lot of times you want to look for ring junctions. So we'd have one, there'd be hydrogens here, not necessarily drawn in. Sometimes you can't necessarily draw in the hydrogens, but there'd be a H here, an H here, an H here, and an H here. So again, so like this carbon, actually there's another H down there. So this carbon's bonded to an oxygen, a carbon, and an H. Now these two carbons are different, but they're bonded to, they'd be different in a CNMR. Again, all these ring junctures, the good spots. H is different than a carbon, these carbons are all different, and so on and so forth as you go around the ring. So identifying 4 different things bonded to an sp3 hybridized carbon. Right, 4 different things bonded to an sp3 hybridized carbon. So here, as you determine whether the following pairs of compounds are constitutional isomers, cis-trans isomers, enantiomers, diastereomers, or identical. For this first one, the trick here is to identify, right, one next to the carbonyl. This has an isopropyl, this one has a methyl. So actually it has different bonding. So those would be constitutional isomers, they have different bonding. Here, everything's the same. If you looked at if you did R and S, the wedge and hatches have flipped. If you use your model kits and determine which one is which, so these are the relationship to each other. They are enantiomers to each other. Bottom one here, no asymmetric centers, so no sp3 with 4 different things. So it could either be identical or it could be cis-trans. And this is a trans or a E alkene. This is a Z alkene, so it's cis-trans isomers. So D through E is kind of a tricky ones. Easiest thing you could do is to number all your carbons. It's just rotating. So here, everything is wedged up. It's also here, so these are actually identical to each other. Right? If you just rotated or numbered your carbons 1, 2, 3, 4, 1, 2, 3, 4, you see they're all the same. Here, this is exactly the same as that, but now what's changed here is we flipped one of these around. So we have one asymmetric center that's different. Those would be diastereomers. If you have at least one different, those are diastereomers. Now here, if everything's opposite, right? OH is flipped, Cl is flipped, Br is flipped, they are enantiomers. So everything's opposite, they're enantiomers. This one, prostaglandins, we're on R and an S. Biggest troubleshooting problem here, one of the common things people make, is that if you're not given the wedge, so there are H's here, and you have to draw them, right, accordingly. You want the wedge and the hatch to be on the same side. You can't do not draw the H here. It has to be over here. And then you got to rank, right, and do your molecules from R and S. So I can draw these H's in, possibly to help you. Right, they'd be wedged, and there'd be an H here. Right, they'd be wedged as well. So the first thing you need to do is make sure you draw the H's in correctly, do your rankings correctly, and then map them on. And that takes a lot of practice. So if I rank this one, this would be 1, this would be red, this would be green, this would be white, this would be blue, right? Red, white, and blue, opposite R, so you can go through and do all those. So that's the kind of practice you need to be able to do on your own. Alright, so looking at ranking some E and Z's, so I have some stuff done here. We want to split the alkene in half. Then we say carbon to carbon. That's a tie, and we see what this carbon bonded to. This one's bonded to a carbon and the 2 H's, or this is bonded to 3 H's, and it's like playing war. High card wins, so C wins. Here, carbon to carbon, it's a tie. We say what else is bonded to? It's bonded to a chlorine, a carbon, and an H. This one's bonded to a carbon and 2 H's, so high card wins, chlorine wins again, they're on the same side. That'd be Z. Another example, move over here, again, splitting the alkene in half. Carbon beats H, based on atomic number, right? We're thinking about atomic number here. Carbon and chlorine has higher number, atomic number, so again, Z, the same side. Another more tricky one here is how many possible stereoisomers are there for the following compound, right? There's actually only 3. We'd expect, right, 2 to the n, right, where n is the number of asymmetric centers. This has 2 asymmetric centers, sp3 with 4 different things, so we expect there to be 4, but there's only 3. So we start drawing these out. If you look at A and B here, A and B have an internal mirror plane. Also, A and B are actually identical. If you flip B over, flipped it on its side, it'd be the same as A, and did the same thing to A. So A and B are actually identical. And we can redraw C and D here, which are different. So there's actually, since these are the same, it's 1, 2, 3 isomers. So when you have a meso possibility, when one of your compounds is meso, you have less stereoisomers than you'd expect. So the relationship A and B are identical. C and D, these are enantiomers, everything's opposite. And A and D, right, they're diastereomers. They have one different stereocenter, at least one asymmetric center is different.